These days, with an ever-increasing demand for comfort and high-tech industrial needs, most modern buildings are air-conditioned. Modern air conditioning systems provide a controlled indoor environment. Most systems provide adequate temperature control. For more sophisticated and industrial applications, the air conditioning systems are designed to control air quality and humidity. Let us see how an air conditioning system maintains a cool and comfortable interior environment. In most central air conditioning systems, the room air is recirculated to the air handling unit, or AHU in short, via air duct. The room air is drawn into the AHU by the suction force produced by the fan inside the AHU. In the larger system, a separate return air fan may be installed in the return air duct to draw the air back to the AHU, where some outside air is introduced. The mixture of return and outside air is passed through a filter before passing across the cooling coil. Inside the AHU, the mixed air around 25 degrees Celsius passes through the cooling coil. After passing through the cooling coil, the air is now cooled down to approximately 15 degrees Celsius. The cooling coil is made of copper tubes and aluminum fins. Chilled water at around 6 degrees Celsius is continuously supplied to the cooling coil to absorb heat from the warmer air. After being cooled, the air is then delivered by the fan back to the room via the supplied air duct. The cycle of air circulation repeats. The heat absorbed by the chilled water raises the temperature of the chilled water from 6 degrees Celsius to around 12 degrees Celsius. The 12 degrees Celsius chilled water after leaving the cooling coil is returned to the chiller at the central plant room. At the chiller, the chilled water enters into the evaporator section. After transferring heat to the refrigerant in the refrigeration circuit, it leaves at around 6 degrees Celsius and flows to the cooling coils of the system, and the cycle repeats. The heat transferred to the refrigerant will be passed to the condenser water circulating through the condenser. After absorbing heat from the refrigerant, the condenser water temperature will be raised from about 29 degrees Celsius to 34 degrees Celsius. The condenser water is then pumped to the cooling tower, which is located outdoors. The heat absorbed by the condenser water is rejected to the outside air. The 29 degrees Celsius condenser water collects in the sump of the cooling tower. It then flows back to the condenser of the chiller to again absorb heat, and the cycle repeats. The variable air volume system, or VAV in short, can be found in multi-zone applications like offices and shopping complexes. In this system, the supply air temperature is kept constant while airflow volume varies with the room temperature. It is most suitable for multi-zone applications because it is an energy-efficient system for dealing with zones that have different cooling loads. In this case, as a result of the additional heat gain in this room, the temperature will rise. Signals are passed to the VAV terminal box, which is used to regulate the supply airflow. The supply air from the AHU at a common temperature is supplied to rooms having different cooling loads. The information that is passed on to the VAV terminal box signals that the room temperature is too high and it needs more cool air to be supplied to the room. The damper inside the VAV terminal box is therefore activated to rotate to provide a larger opening position to increase the supply air volume flow rate. As a result of more supply air, the temperature of the room is returned to its set point temperature. If the temperature of the room drops, the damper plate will rotate to close, thereby reducing the supply air volume flow rate. The fan coil unit system, or FCU in short, can be found in places like hotel rooms, offices, and shopping centers. It is versatile in terms of design and layout, especially where there is space constraint. Unlike systems that require extensive ductwork to deliver cool air to the air conditioning space, chilled water is piped to the FCUs located within the space. The chilled water pipes are connected to the cooling coil of the FCU. Room air is drawn into the FCU, where it is cooled and dehumidified before being supplied to the room. The FCUs have filters located at the upstream of the fan. The filter cleans the air and hence reduces the level of airborne contaminants within the air-conditioned space. When there is a change in the room temperature, the room thermostat will send a signal to activate the automatic control valve. The valve will then open or close to regulate the chilled water flow to fan coil unit to provide the right amount of cooling to the circulating air. The system provides flexibility for zones requiring individual control. Room thermostat allows occupants to change a set point to the desired temperature. This thermostat also provides the selection of fan speed, controlling the supply air volume flow rate to the conditioned space. Designed for energy conservation, the fan coil unit can be switched off when the room is not in use.